Hello guys, welcome to another obviously lecture video. Maybe this might be your last just because we might have class in the classroom, which would be nice. This way you guys can actually ask me questions during it and take notes. But just know today we are going to get through 6.1, the whole thing. It's going to go pretty quick. This is an intro to just these main systems of the atmosphere. I think I kind of said this in the actual classroom that this 6.1 is really a recap on many things that you might have learned in the past or should have. I actually teach these same concepts to my middle school earth science class, so do know it's kind of a step back, but now we're going to kind of look at those same systems and mainly focus on the environmental systems type of thing, right? How they are regarded in environmental systems in society. So please sit back. Obviously, you have a little bit of work to do in your workbook, a couple of videos to watch to do your workbook, a couple of notes to take. So take good notes, put good thought into your, even though this is very quick, put some good thought into it because it kind of sets up the rest of 6.2 and 6.3. So sit back, relax, take some notes. All right, so introduction to the atmosphere. Really, it's important to understand, just kind of sum this slide up, but it's important that when we're talking about the atmosphere, there's tons of inputs, outputs, flows, and storages, right? And as we're going to see, they've been kind of going through changes with the influence of humans. Do know that obviously there's a lot of stuff going on. There's the sun, that's an input. We have plants and animals giving off CO2 and oxygen, depending on which organism it is, right? That is changing the dynamic of the atmosphere. You have heat that changes the dynamic of the atmosphere, and then you have these type of systems that they all kind of come together, and then you have precipitation, you have rain, you have all these things kind of going on. So do know that just like everything else in environmental science, there's tons of inputs, outputs, flows, and storages. You should be, whenever we go through anything, you should be kind of thinking about through these systems, right? And do know it's the atmosphere is not a simple system, I would say. It may look simple when you kind of first look at it, but do know that there's so many things that change it, and it's changed throughout Earth's history as well. That really can kind of, if you start changing one little dial, the whole thing starts to change, right? Big hint here, global warming. We'll definitely start talking about that in this chapter. Humans are adding a little bit more CO2 to the atmosphere, which then changes the whole dynamic of it, right? So do keep that in mind when we're kind of going through this section. We're going to talk about things like weather versus climate. Obviously, weather is very short period events, where climate is long-term events, and we're changing these long-term events and short-term events as well. And we will kind of discuss about how organisms play a huge role in that. Humans are not the only organisms that have changed Earth's atmosphere. There were times of higher CO2 or oxygen, depending on the time period, as a result of many organisms that have been on this planet. And you'll kind of do a little research on that as well in this unit. And then they kind of take you back, but remember what James Lovelock, author of, the Gaia hypothesis, he really, once again, he viewed, the atmosphere as all these systems due to the organisms on, Earth changing, and then that changes the atmosphere. So do keep that in the back of your mind as well, right? And finally, to kind of stress his point as well, that, what we have on this planet now, the organisms on this planet, have evolved to fit what's in the current atmosphere. If you change that atmosphere, the living organisms that have adapted to live in that type of environment are going to be greatly affected. So keep that in mind, okay? I'm going to roll through this, but please take your time to kind of look at all these. But I'm going to kind of give you the rough breakdown of the atmosphere. Most of our atmosphere is nitrogen, 78%, oxygen, 21%, argon, 0.9%. Carbon dioxide is 0.03. So there's very little carbon, or at least naturally, in the environment. You change that 0.03 very slightly, everything starts to change. Water vapor makes up to, it just depends on the area you're in, from very dry to 0% of the air, which is very highly unlikely, but does happen, to 4%. And then we have very many trace gases, like neon, helium, krypton, and xenon, helium as well, or I guess I already said that, but many different types of gases in that last percent. And here's just kind of a breakdown of that in graph form. I think there's actually a section in your workbook to do that. So go ahead and pause this if you need to, but I'm going to continue right along. All right. Human activities impact the atmospheric composition through altering inputs and outputs of the system. Changes in the concentration of atmospheric gases such as ozone or carbon dioxide or water vapor have significant effects on ecosystems. It's key to understand that. If, like I said, carbon dioxide, we're really going to talk about that one. We will talk about ozone as well, but to kind of give you, to talk about the big one, global warming, right? It's carbon dioxide in the atmosphere is 0.03. You start changing that to 0.031, 0.035. That's huge amounts of increase. Even though it doesn't sound like it, it has a complete change in dynamic of the atmosphere. Thus, you're going to have different changes. You start changing one knob, it starts changing all these other ones. So if you start increasing it or decreasing it, you're going to have these big problems associated with the environment, as well as it's going to affect all the living things that are set to expect the 0.03% of carbon dioxide. We will talk about other ones. Obviously, it's not just CO2 or carbon dioxide. We'll talk about chlorofluorocarbons, increasing those. Ozone, methane is a big one, absolutely, with cattle production. And just water vapor. And I know you might say, well, there's always going to be water vapor. Well, just think about this. Let's say we start creating CO2 or methane. We put more of that in the atmosphere, which then increases the heat on Earth. Well, when you have that increased heat, what do you get? More energy in water molecules. So then more water molecules go in the air. So if you start changing just CO2, then it increases water molecules, right? It's a kind of a runaway effect. So these are things to kind of keep in the back of your mind when we're going through this unit. Very quickly, and I think your workbook actually has you do a little more investigation on these. I'm not going to spend too much time on them because we'll really talk about the troposphere mainly. But do know that the Earth's atmosphere does have different layers. From the very top, and we can even get to there's actually more layers if you break it down, but the main ones: thermosphere, mesosphere, stratosphere, and then the troposphere. Troposphere being the one that is all around us, that we will talk about mainly on this one. But do know there are different layers to Earth's atmosphere. And here you go. Here's a nice little graphic for you there. And like I said, we will be talking mainly about the troposphere. Why? Because that's the one we live at. It's the lowest and thinnest layer. It's roughly about 16 kilometers at equator, 8 kilometers at the poles. So it's not uniform thickness. Temperature decreases with altitude. The higher you go up, the colder it gets, and roughly 6 degrees Celsius per kilometer. So every kilometer you go up, it roughly changes about 6 degrees. And then the top of troposphere averages about negative 50 degrees Celsius. So it's freezing up there. And this is where weather balloons, where weather also occurs. And this is the boundary between the troposphere and the stratosphere is called the tropopause. So kind of keep that in the back of your mind as well, and we'll kind of discuss that layering. But once again, as we jump into 6.2, 6.3, we're really going to talk about mainly the things that are happening on the troposphere, because that's where we live, and that has the greatest effect on life on this planet. Another key thing that we will continually bring up, the 6.1, we're going to be talking about them, I think, for the rest of the year, really. But do know that most clouds form in the troposphere and play an important role in the albedo effect of the planet. Also think of, we'll say this word again, albedo, in regards to like the polar ice caps, right? Albedo is just a really just a measurement of the reflectivity of a given surface. White has a higher albedo than black. So if you are wearing a black shirt, the sun's rays are going to hit you, and you're actually going to get hotter. Why? Because your shirt, because it's black, actually holds in more heat. Mosquitoes are more attracted to black type of things. Why? Because they hold in more heat. They don't reflect the light back out. Where if you're wearing a white shirt, it tends to reflect that light back into outer space, into the universe, right? Because the sun hits it and bounces off more freely. So these are important concepts that you need to understand, because we're going to be speaking on them in the future, right? So more clouds have more reflectivity in them, and just know that that's key to understanding when we get to global warming, and we'll talk about it more. Okay. Anything else I need to say in this one? I think the key part is, but we're going to talk about this quite a bit, is, do know that overall, different albedo reflects, the higher the albedo reflects more of the sunlight. Do know that, not all the sun's rays come in onto the planet and stay on the planet. Most of them end up bouncing back out into space. Now, when you start adding more molecules around, CO2, methane, solar radiation tends to stay within the atmosphere more. That's why we have a heating thing, and we'll kind of get into that a little bit more, obviously, in our global warming unit. But here's just kind of a nice graphic that kind of shows you, where kind of, if a cloud has low albedo, more kind of gets through, stuff like this, and with low level clouds versus high level clouds. So just kind of keep this in the back of mind, especially I think there's a workbook section for this to kind of look at this and to kind of understand what it's saying. But like I said, we will be discussing this quite more in the future, but this is just kind of a basic understanding of it. Okay. And then the greenhouse effect of the atmosphere is a natural and necessary phenomenon maintaining suitable temperatures for living systems. We are going to go through this much more extensively. I am kind of rushing through it. I do know that, but just know, because I know you kind of get a base of it, and we're going to break each of these down quite a bit more in the further units. And I'll kind of read this, but the term greenhouse effect is commonly used to describe the increase in Earth's average temperature that has been recorded over the past 100 years. However, without the natural greenhouse effect, life on Earth would be very different than it is today. Just know that there is a natural greenhouse effect. Earth always kind of holds in some of this heat. If we didn't, we would be frozen wasteland. So do know that there was always kind of a greenhouse effect going on. There's always kind of that atmosphere kind of creates a blanket effect on Earth, right? It keeps us kind of nice and cozy in this perfect temperature. Now, let's say, humans and all species on this planet are used to, this thick of a blanket over them, keeps them perfect temperature. Well, let's say you start throwing another blanket on, or making that blanket even more thick. Well, you're going to start getting a little bit warm, right? And having these big effects. So that's kind of what's going on. But, the role of greenhouse gases are maintain mean global temperature, kind of keeps it a steady temperature. If we didn't have it, it would be super hot during the day because all that solar radiation is going right through and burning life. And then at night, it would absolutely be a frozen wasteland. So it kind of maintains that heat for us. It's a normal and necessary condition for life on Earth, and it allows short wavelengths of radiation, such as visible light and UV, to pass through Earth. But just know that, this starting to change that dynamic, and, we trap longer wavelengths, such as infrared radiation, right? I guess what I'm trying to say is there's always a natural, greenhouse effect that's going on Earth, but humans are slightly changing that, adding a little bit more blanket to our, cover that, we are having on Earth, and that changes everything. And we'll talk about that more. This is a graphic you're going to see quite a bit in the future, but this just pause me here, look at it, learn it, understand what it's trying to tell you. And it's really, it's really just showing you that, the Earth's solar radiation is coming in short wavelengths and long wavelengths. Some of those, get bounced. Some of them stay on Earth's surface. Some of them get bounced back out into the universe, and then some are getting trapped within that. So please take a look at this. You will see this again. It is crucial that you know this, because obviously this plays a huge role in our final chapter, which is greenhouse unit, our final unit, greenhouse effect. And I think we already kind of talked about this, but discuss the role of albedo effects from clouds in regulating global temperature. So think about it. Remember, albedo is the reflective processes of Earth's surface and clouds or different surfaces to reflect heat and solar radiation back out into the universe, right? Some of it stays, some of it leaves. So start thinking about these things. Keep this in your mind, right? So how I would put this is, put it simply. Let's say you have a house, right? Your roof is either white or black. Well, which house is going to be hotter, right? So you should think about that. Well, obviously, what I kind of the terms I already told you, the black house is going to get much, much more hotter, much more quickly, because it's holding in more of the solar radiation. Now, think of that on grand scale. Let's say we have the North Pole, which is all ice. What color is ice? White, right? Now, is that white going to reflect, going to heat up quickly, or push most of it back into space? It's white. It pushes most of it back into space. Now, let's say we start melting that ice, and it becomes ocean, a dark blue, dark, purplish ocean. Well, where's the heat going to go then? Is it going to be bounced off as much? No, it's going to start getting more and more absorbed by the Earth, right? These are problems that are associated with it. So start thinking about these on these grand scales, and use that example of the house that I gave you kind of earlier, right? So read this, but kind of understand that's the main point, right? The albedo effect has a significant impact on our climate. The lower the albedo, the more radiation from the sun that gets absorbed by the planet, and temperatures tend to rise. If the albedo is higher, Earth is more reflective, and more radiation is returned to space, and the planet cools. So there needs to be this nice medium, and we're starting to change that. Okay, and here it kind of shows you the difference, right? Shortwave reflection of Earth's surface kind of goes through. Much of it is bounced off. In this first picture, we're seeing the solar radiation, but then also at the same time, do know that if you have a lot of CO2, the heat that is stuck underneath the cloud tends to stay underneath the cloud. This is just kind of with long wave radiation. So also, you can think about it like this. This is another key of how I always remembered it, is on a clear night, if there's no cloud coverage, usually it tends to be slightly cooler, because nothing is holding in that heat or long wave radiation. Now, if it's overcast, a lot of clouds, well, it tends to keep that temperature stable, because it's acting kind of like a blanket. We'll discuss that more in the future. Okay. And then, I think we already kind of spoke on this, but outline the role of greenhouse effect on regulating temperature of Earth. We're going to get into this a whole unit on it. It's a quick unit, but just know that it's a whole unit. But just know that, when it comes to greenhouse effects, just know that, kind of think back to that blanket analogy I gave you, right? The more blanket you have, obviously it's going to trap in more heat and keep the heat in. So think of, if you start adding more CO2 or methane molecules into the atmosphere, well, they're trapping that long wave, and it's not being released into the universe. So it's going to get warmer and cozier in here. Now, I put it a nice spin on it, like we're getting a little bit warmer. It's not that nice, obviously. There's certain, if you just change the temperature 1.5 degrees Celsius, has disastrous effects on the environment. Things start to die, changes the water system, changes the water molecules. So all these things do change, and we'll talk about this much more in the future. Okay. All right. See, that was pretty quick. Kept it under 20 minutes, guys. Go ahead and finish workbook 6.1. But like I said, I know I rushed through this part, and it seems like it's a lot of information, but it's just the basic. We will get into this much more in the future on all these things. We'll break them down, and you are going to know these. All right. That is it. Have a good day. Enjoy.